Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, to calculate a particular EMF of a cell, we should know what is the electrode potential, and then only we could understand what is the cell potential. So let us see what is electrode potential and what are cell potential related to it. So talking about electrode potential, it is defined as the difference of electrical potential between a metal electrode and solution around it under equilibrium condition. As you know that we have taken an example of Daniel cell also. In Daniel cell, what happens that we are dipping zinc electrode in ZnSO4 solution as well as copper electrode in CuSO4 solution. So in this case, the metal, that is zinc, which is dipped in ZnSO4, this creates a potential difference between the metal and the solution in which it is kept. And in this case, when the reaction occurs at equilibrium, a kind of potential has been creates. So this create a potential, and that potential is said to be an electrode potential of that particular electrode. So let me give an idea that how kind of, or how do this kind of potential are being generated, or how do this differences are being generated when a metal is being kept in a solution of its own ion or in other ion also. So let me talk it about the first one, that is the origin of the electrode potential. This is the origin of the electrode potential, that how the potential on a particular electrode arises. So when a metal plate is been dipped into a salt solution, the metal have the tendency for oxidation also. So suppose if this is the metal, this green rectangle, I have drawn it as a metal. Suppose if this is the metal that I have been dipped in a solution which consists of its ion. So in this process, what happens is the metal has the tendency to lose electron, or the metal has the tendency to show oxidation process. So as the metal will show Mn plus, or it will convert into Mn plus Ne, it will donate n number of electrons. So in this process, what will happen is whenever the metal will oxidize, so it will convert into its ionic form. So therefore the ionic form will be dissolved in the solution itself, but the electron that are being left, they are being left on the metal itself. So in this case, as you could see, during oxidation, the electrons are being left within the metal itself, while the Mn plus ions, they are being collected, or they are being mixed, or they are being dissolved in the solution. So this will create a potential difference. How? So the overall solution will have a positive charge over here, while the metal will acquire negative charge. So this makes a difference in generation of a potential. So this negative charge and this positive charge will form a double layer, and this double layer plays a very vital role in the generation of a potential of a particular electrode. So suppose if the forward reaction is faster than the backward reaction, then only this will generate a negative charge on the metal as well as the positive charge on the metal outside the metal when the Mn plus ions are more, and the oxidation process is more faster than the reduction process. So in this case, a potential difference can be generated. The another method to form a generation of potential on a particular electrode, if the metal undergoes reduction. So metal in an ionic form can undergo reduction also. So in this process, suppose the metal ions in the solution have a tendency for reduction. That's fine. So that Mn2 plus or that Mn plus will accept electrons to form the metal which is in solid form. So in this process, what happens is the metals the metals which are present in ionic form, that is Mn plus, they all will try to gain electrons which are present on the metal. So in this process, what happens is, as we have already known, in this process, that is at equilibrium process, suppose if the metal acquires a negative charge. So all the metals which are present in the ionic form, they have the tendency to again gain electron, so they will combine with the metal so as to abstract electron from the metal plate. So in this process what will happen is the metal plate will lose electron, and the electron will be accepted by Mn plus. So since the metal plate is been losing electron, and the overall solution will acquire a negative charge, and in this process all the Mn plus ions will accept electron and they will deposit on the metal plate. So in this process the reduction process takes place, and in this process suppose if the reaction is at equilibrium, and the forward reaction, that is when Mn plus will accept n times of electrons, if it undergoes a reduction process, then this process will acquire a positive charge on the metal plate. So this is the possibility where a metal can acquire a positive charge as well as a metal can acquire a negative charge, when we consider that a metal which is undergoing oxidation process and the metal ions which are undergoing reduction process at equilibrium. So again in this case also a double layer is being formed. As we could see, a positive layer is formed on the metal, while within the metal, while the negative charge are around the metal. So in this case a potential difference is being created, and hence the electrode potential is being generated for a metal when it is dipped in a particular salt solution. So in this case, in electronation, that is in de-electronation, that is in oxidation, and in electronation, that is in reduction, in both the process, as we could see, there will be a formation of double layer, and in this case during the formation of a double layer a kind of potential is informed, and hence this has an origin that an electrode can also have a potential on it. So this is said to be the electrode potential, and this is how the electrode potential is being generated. So now let us talk about, there would be two types of potential that would be generated on a particular electrode, that is during oxidation and during reduction. So now let us talk about what will happen if the electrode potential that is being generated during oxidation. So this is the one, that is oxidation potential. And what does oxidation potential means? So the potential associated with an oxidation reaction at an electrode is called as an oxidation potential. So a potential that is being developed when the electrons are being donated by a particular metal atom, that is, it is known as the oxidation potential. For example, in this case I have took an example of zinc, which is present in a solid form, that will be converted, or that could be at equilibrium, that will be generating Zn2 plus, while also eliminating 2 electrons. So during this process of oxidation, it has been calculated that the potential during oxidation of the zinc was found to be 0.76 volt. So this is the kind of a double layer that is being generated, or a kind of potential that is being generated when zinc is undergoing oxidation, and this will happen when the zinc material is being placed in a solution which consists of ZnSO4 or consists of a salt solution. So this was the oxidation potential of a particular electrode. So now talking about the next one, that is what is reduction potential. So this is the reduction potential. So let us see the definition of it. So the definition says that the potential associated with the reduction reaction at an electrode is called as the reduction potential. So any kind of potential that is being generated when the metal ions are being accepting electrons from the metal itself, when the metal carries a positive charge. Why? Because the electrons are being accepted by the metal ions which is present in the solution. So in this case what happens is the Cu2 plus will accept 2 electrons so as to form Cu. I have taken an example in this case. So in this case the Cu2 plus ions which are present in an aqueous form will accept 2 electrons so as to form copper. So this is nothing but an equilibrium process in which reduction occurs, and the reduction potential of this copper was found to be 0.337 volt. So this is how, when a metal ion will accept electron and a double layer is being formed, so this is the potential that is being produced during reduction process. So we have clearly indicated and we have clearly known that what is oxidation potential and what is reduction potential. So talking about this, where the potential of a particular electrodes. So when an electrode can act like an anode, or the electrode can act like a cathode also. So in this process, let us see what is the overall cell process in which we are using anode as well as we are using cathode. Because as you know, at anode oxidation will take place and at cathode reduction will take place. So the potential generated at anode will be the oxidation potential, while the potential generated at the cathode will be the reduction potential. So if we combine this two, then only a cell potential can be created. So it is very essential for us to understand what is a cell potential. So this is cell potential. Let us see what is the meaning of it, and let us see what kind of formula that we could derive from a cell potential value. So it is nothing but the difference of potential between the electrodes, which is corresponding to an external flow of electrons from anode to cathode, is known as cell potential or EMF of the cell. And talking about this thing, in a very easy way, I could make you understand that what does the EMF of cell or what does the cell potential of a particular cell means. So basically, E cell, which is nothing but the EMF of the cell, or you could say the cell potential of a particular cell, is the combination of, or it is the sum of the cell potential during oxidation at anode, because oxidation takes place at anode, and the cell potential, the reduction potential at cathode, because at cathode reduction takes place. So this both combination will give the overall cell reaction, or this overall cell EMF or EMF of the cell. So we also know that if I could say that the E, that is oxidation, the potential of oxidation at anode will be the reverse, that is minus of the reduction at anode. In this case, suppose if I would say, if we have taken the example earlier also, suppose this was an example of reduction potential of copper, which was found to be 0.337 volt, which is positive. Suppose in this case, if I have to calculate what would be the oxidation potential of copper, then it would be the reverse of it. That is, if this is plus 0.337 volt during reduction process, then during oxidation process it would be minus 0.337 volt. So therefore we could write in this formula also that when the reduction potential is the opposite of the oxidation potential, and since both are occurring at anode, so only the sign will change and while the rest will be the same. So this can be easily written as the E cell, which is equals to, instead of oxidation of anode, I could write it as minus E reduction at anode. So I could write it in this way, that is EMF of a particular anode during reduction plus reduction potential of a particular cathode. So overall I could write it as E reduction of cathode minus E reduction at anode. So this is the formula that how can we calculate the cell potential of a particular cell by making the difference between the cell by making the difference between the potential of a particular cathode and difference of a reduction potential of a particular anode. So this is how we can calculate the EMF of a particular cell or the cell potential of a particular cell. So it was so much easy. And nowadays, the thing that we should understand is that only the reduction potential are being used, not the oxidation potential. So therefore, this is the overall formula that would be very much helpful in the future while solving the numericals also. So now talking about the next one, this is the EMF that is not being dependent on any criteria, because it can change with temperature. If the temperature increases, then EMF of the particular cell will also increase or decrease. If the concentration of a particular cell, as you know that the cell, the electrodes are being dipped in a solution, but that solution can be of 1 molar, 2 molar, it can be of any concentration. So it depends on the concentration also in which a particular electrode is been dipped. And while talking about the nature of the solvent that are being used, so it depends whether the electrolytes are strong electrolytes or weak electrolytes, or which kind of electrolytes they are used. So based on this thing, the EMF also depends on it. So let us talk about those standard potentials which are not dependent on this kind of criteria, or whose value remains constant throughout the cell reaction. So they are said to be nothing but the standard oxidation potential we are now going to talk it about. So it is similarly like the oxidation potential, but what is standard oxidation potential actually? The potential for the oxidation half reaction that occurs at electrode when all the substance involved are in their standard states, which is known as standard oxidation potential, and I denote it by E naught of oxidation. So in this case, what is the standard states? Suppose if I talk about the concentration, then the standard concentration of a particular electrolyte should be 1 molar. If I talk about a particular liquid, or if I talk about a particular gas when it is being used as an electrolyte, in case we are using a standard hydrogen electrode. So the pressure that should be maintained should be of 1 atmospheric pressure. So this are the standard values that should be maintained, and then only the potential that is being generated can be said to be an standard oxidation potential. So this is the standard value that depends when all the criteria are present in unity or are present in a standard value. And talking about the temperature should be maintained at 25 degrees Celsius. So these are the standard states or the standard values where a potential is being generated, or the potential that has been calculated in this criteria. So this is said to be a standard oxidation potential when an electrode undergoes an oxidation process. And now talking about the other one, that is standard reduction potential. So this is similar like the reduction potential, but the difference is the criteria or the condition should be in a standard state. So let us see the definition of it, and because of the help of this we could evaluate the other thing also. So it says that the potential for the reduction half reaction that occurs at a particular electrode when all the substances involved are in their standard states is known as standard reduction potential. So as we know earlier only in this lecture that we know that a particular electrode can undergo oxidation process as well as a reduction process, and the potential that has been generated during that is known as reduction potential. But suppose if the standard states, that is if the electrolyte in which it is been dipped has a concentration of 1 molar, and the pressure, or if the pressure is been also maintained at 1 atmosphere and the temperature is been maintained at 25 degrees Celsius. So these are the standard criteria that should be maintained, and the potential that has been generated or that has been calculated during this condition is said to be a standard reduction potential. So simple. But we could denote it in a very easy way, that for a standard reduction potential I could denote it as E naught, and since we are talking about a reduction potential, so I could name it as E naught of reduction for a particular electrode. So now let us talk about what would be the cell potential. So reduction potential of a particular electrode and oxidation potential of a particular electrode has been discussed. Now let us talk about the standard cell potential. What would be it? So again, talking about this, so the standard cell potential is nothing but the potential of a galvanic cell when all the substance involved in the cell reaction are in standard states is known as standard cell potential or standard EMF of a cell. It is denoted by E naught cell that I have written. So in this process, as we did earlier also, that it is the difference between the reduction potential of a particular cathode and reduction potential of a particular anode, and by the help of this we could estimate that what would be the EMF of a particular cell or the cell potential of a particular cell. So in this process, as we know that E naught cell will be the summation of the potential oxidation potential of anode and the sum of the reduction potential at cathode. But recently we have known that this E naught of oxidation that takes place at anode again can be written as minus E naught of reduction that takes place at anode itself. So both will be different, both will be the same, but they will have a different sign. One will be positive while the other will be on the reduction will be negative. So this thing can be substituted in this formula, so we could get E cell is equals to, I would write it directly, E naught of reduction value for cathode minus E naught, that is the standard potential during the reduction process at anode. So this is the formula that we have evaluated, and this would be very much helpful in the future. So by this process and by this theory, we have understood what is cell potential, what is electrode potential, what are the standard oxidation potential, what is standard reduction potential, and many more. So this was a very important and crucial topic so as to understand what are the terms involved in electrochemistry related to this, and this plays a very vital role in the further study so as to evaluate the different kind of questions as well as a theory which is related to electrochemistry. So thank you friends for watching this video. I hope you have liked this video and you have understood many much more concept in this long video. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.